Imagine a typical trip to your local grocery store. You're heading inside to get your assortment of fruits and vegetables for the week. You think about getting some apples, some spinach, some bananas, and maybe some grapes too. But have you ever wondered, how did these foods get here? How are all these fruits and veggies this big and nutritious? Does it matter? If you asked any of these questions, the answers might surprise you. To answer those questions, we have to establish what GMOs are and the significance of their history. According to the Institute for Responsible Technology, a GMO is the result of a laboratory process where genes from the DNA of one species are extracted and artificially forced into the genes of an unrelated plant or animal. The foreign genes may come from bacteria, viruses, insects, animals, or even humans. Because this involves the transfer of genes, GMOs are also known as transgenic organisms. So, how do they work? Well, certain genes enter a crop and can alter how it looks, tastes, and even how they can last once put into the market. Now, can you tell me what this is? It has seeds, so it's obviously a fruit, but what fruit is this? A big grape? Some sort of weird honeydew? Well, it's actually a banana. Now hold on, there's no way that small dinky thing is a banana. How did this happen, I hear you asking? To clarify, this is a wild banana traced from hundreds of species through the research of C. Linifer and W. Boyd. This was a banana cultivated about 7,000 years ago in Papua New Guinea. As you see, these bananas are much smaller, greener, and actually have seeds compared to the bananas we eat every day. And since you notice those differences, the development of the banana through domestication and cultivation has led to amazing results. Bananas have been transformed to be that sweet and creamy fruit we all know, while still being sturdy with its peel to transfer it across the globe and last long when you put it on your shelves. This has been achieved through generations of genetic testing and alterations. And with scientific advancement, we are now seeing tests on bananas to alter their code to fight against diseases caused by bacteria. For example, a study has been conducted about classes in Uganda dealing with diseases in their bananas, which is a major crop in the country, and found that new genetically modified bananas varieties are favored in poorer households and could benefit in welfare gains in those specific commercial sales. While it is true that the urban population has no use in this strand, it is key to highlighting its effects on the lower classes. This demonstrates how GMOs could improve standard qualities of life and health, and shows how important GMOs are in the grand scope of our food. So, what is the purpose of me explaining the history of bananas? Well, everything really. It deals with our food, and GMOs are very essential to our future. GMOs have existed for many years, so it's important to protect them and protect your rights to eat whatever food you want. So, how can you help? You can join a scientific literacy organization that promotes environmental concerns and supports inclusionary regulatory GMO campaigns. Also, avoid companies and lobbyists that try to sell organic and do not support alternative methods for making food for profit. Also, sending donations to your local university or institution that researches genetics and sign for alerts and notifications from said genetic research can help contribute to scientific literacy and development. We have been altering our food with genetics for many years and haven't even realized it. GMOs are important because they're a part of our food and can help contribute to a healthier and more stable environment.